Okay, scientific notation is just a kind of a neat, easy way to represent really big numbers and really small numbers. Now, I'm not going to use a really big number. Um, well, let's say, well, we'll just give you an example. I have these ready here. Um, like, here's an example of a really big number that we might want to express. The mass of the Earth. How much mass does the Earth have? Well, 5.972 times 10 to the 24th kilograms. That's a pretty big number. In other words, 5.972 times 10 times 10 times 10 times 10 times 10, 24 times. It's times 10 to the 24th power, which is 10 multiplied by itself 24 times. So every time you multiply by 10, you turn to 59, and 597, and 5,972, etc. So we were talking about a really, really big number. Um, there'd be a lot of zeros on the back end of this number. Now, on the other hand, we can also talk about really small numbers, like the mass of a proton. The mass of a proton, which is just part of an atom, is about 1.67 times 10 to the negative 27th kilograms. In other words, this 10 to the negative 27th power, remember from our exponent rules, that's 1 over 10 to the 27th power. So we're multiplying this 1.67 by a super small fraction. 10 to the negative 27th is a super small fraction. It's essentially the same as taking this 1.67 and dividing it by 10 27 times. And every time you divide by 10, the decimal point goes to the left. So you'd have 0.000000, like 26 zeros, followed by 167. So it would be a really small number. Now, so this is much more convenient than writing 26 zeros out there in front of the one after the decimal point. That's the purpose of scientific notation, for writing really big numbers or really small numbers. So let's say the number 5,000. Suppose we wanted to write that in scientific notation. Well, scientific notation, you only put one digit. Let's make it something else. Let's make 5,287. You only put one non-zero digit in front of a decimal in scientific notation. So 5.287. So we ask yourself, what do you have to multiply the 5.287 by to get, how many times do you have to multiply 5.287 by 10 to get 5,287? Well, the decimal had to move 3 places to the right, so it got multiplied by 10 3 times, by 10 to the third. Suppose we want to convert 0.002, let's put a few more zeros in there, 0.0000416. Well, in scientific notation, that will be 4.16 times 10 to, now here we have to multiply in order to get this really small decimal, we'd have to multiply 4.16 by a really small fraction. In other words, it's going to be a negative power of 10 that it gets multiplied by. 4.16 times 10 to the negative something. Well, how many times did the decimal, how much space is there between the 4.16 decimal position and the actual position back there? 1, 2, 3, 4, 5 places. So 4.16 times 10 to the negative 5 will be the same thing as 0.0000416. And to convert from scientific notation to standard notation is actually easier. I probably should have done that first. 4.7 times 10 to the 6th. Well, that says multiply the 4.7 times 10 times 10 times 10 times 10 times 10 times 10. And every time you multiply it by 10, you're either moving the decimal one place to the right or adding a 0. So 47, that's 1, 2, 3, 4, 5, 6, 4,700,000. If this had been negative 6, 4.7 times 10 to the negative 6, you're multiplying by 4.7. 4.7 times 1 over 10 to the 6th. In other words, you're dividing by 10 to the 6th power. So 4.7, we'll start with a 4.7, and we've got to go 1, 2, 3, 4, 5, 6 places to the left. And we have a 0 there, 0 there, 0, 0, 0. So 0.0000047 is what that would equal. Now, if you're multiplying numbers in scientific notation, like let's say we want to multiply 3 times 10 to the 5th multiplied by 4 times 10 to the 6th. Well, 3 times 10 to the 5th times is really just 3 times 10 to the 5th times 4 times 10 to the 6th. Multiplication can happen in any order, so let's reorder it. 3 times 4 times 10 to the 5th times 10 to the 6th. 3 times 4 is 12 times 10 to the 5th times 10 to the 6th. 10 times 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 10. How many times is 10 multiplied by itself? 11 times. Now, the problem is you're probably going to be asked to express this answer in scientific notation. 12 times 10 to the 11th is not scientific notation. You could only have one decimal, one non-zero digit in front of decimal. So we've got to change it to 1.2 times 10 to the something. Now, I took this 12 got divided by 10 to get 1.2. So to counteract that, I need to multiply the 10 to 11th by 10 again. So it will now be 10 to the 12th. So it makes sense, really, if you've got to multiplying 12 times 10 11 times is the same as multiplying 1.2 by 10 12 times. Now, suppose we divide, 6 times 10 to the 7th divided by 2 times 10 to the 10th. Well, 6 divided by 2 is 3. 10 to the 7th divided by 10 to the 10th. Think about your exponent rules. You'll end up with 3 extra 10 to the 7th divided by 10 to the 10th is when the tens cancel out, you end up with 1 over 10 cubed, which is 10 to the negative 3 power. You could also think about the subtraction rule, subtract the exponents. So that's 3 times 10 to the negative 3 power, and that is in scientific notation because you have one digit in front of the decimal, 3 point. That's pretty much how scientific notation works. I guess there would be one other kind that you could do. It would be like 1.2. So we want to do 1.2 times 10 to the 12th. And we wanted to raise that to the 3rd power. 1.2 times 10 to the 12th times 1.2 times 10 to the 12th times 1.2 times 10 to the 12th. That's just going to be 1.2 times 1.2 times 1.2. 1.2 cubed times 10 to the 12th cubed. A calculator would be the quickest way to find 1.2 cubed. Let me just grab a calculator real quick. 1.2 cubed, 1.728. 1.728 times 10 to the, well, 10 to the 12th power cubed, that's 10 to the 12th times 10 to the 12th times 10 to the 12th. How many times is 10 multiplied by itself altogether? 36 times. That's how scientific notation works.